All right, good morning, everybody. We're a couple minutes late here, so I'll go ahead and get started. This talk is going to be on mobile security, mobile forensics, and mobile malware analysis with the distro that my company's built a couple years, I guess a little over a year ago now, called Santoku Linux. So this will be kind of hands-on. I'll give you some background information with some slides, but I'm going to do some live demo stuff as well. Just my background, I'm the co-founder and CEO. Got a number of books published. I stay pretty active on the technical side of things, and so I do speak at a lot of different conferences and things of that sort as well. And just my company, we've been around since 2009. We've got right around 40 employees, and about 10 of them are focused on really hardcore mobile R&D. And so you'll probably know some of their names from different conferences and things of that sort. We also try to contribute a lot to open source. And so these are just a few of the projects that we've done. We just recently finished up a YAS2 module for the sleuth kit. So if you're doing Android forensics work and you use the sleuth kit, we've got a module in there now to parse the YAS2 file system. One of the things I'll show you today is AF Logical, which is an open source Android forensics package you can use to pull data off of Android devices, and of course Santoku Linux will be a big part of what we talk about. If you're on the application development side of things, we also publish a best practices document for what are all the things that we see developers do wrong when they write mobile apps, and how do you do it the right way. So there's best practices, tons of presentations. You'll find all of this on our website, so there's a lot of free stuff. Go out there, check it out. We try to put as much out there as we can. So the question is why did we do Santoku? And what we found was that obviously we're a mobile company, and just to give you some stats around that, these are numbers that IDC provided I think earlier this year. In 2012, looking at laptops, desktops, tablets, and smartphones worldwide, there were 1.2 billion new devices bought in 2012. And you can see over here that desktops and laptops represent a chunk of them. Tablets are, a bit lower, but getting right around the desktop numbers. But smartphones are by far the biggest, at approaching 700 million devices. If you look forward to 2017, though, desktops go down a little bit, so we're still going to be using desktops. We're going to replace them. Laptops go up quite a bit, but here's the real growth. You see about triple growth in tablets, maybe up to 700 million, and then smartphones are literally off the charts, with about 1.5 billion new smartphone and mobile devices will be bought. When you think about the number of mobile apps that sit behind that, you basically have a tremendous amount of velocity in this market. A lot of challenges that I think enterprises and people are going to be facing about how do we secure it, what's going on, what's operating. And so we looked at that market, obviously, and we built a company around it and said, what are the tools that you need to kind of get involved in this space? And so this is a snapshot from our previous version of Santoku, just some of the tools that we pre-bundle for you guys. And what we found was that our development and R&D teams were spending hours running the latest tool, getting it updated, repackaging it, and then we would take the output from one version and another guy couldn't use it. And we said, this is silly. We've got a business built around this. Let's get some consistency. Let's get that out to the community as well. So we started taking best-of-breed tools that we use for forensic security malware analysis. We put it into an Ubuntu ISO, and we set up a .deb repo so that you can easily just go out there, apt-get, update, and pull down the latest tools without having to build them yourselves, which can take quite a bit of time. You can download the ISO straight from Santoku Linux website. If you already have your version of Linux up and running, you can literally just add our repo to your current Ubuntu box or Debian compatible box, and then just do apt-get install Santoku, and it'll pull down all the tools and dependencies for you automatically. So, and after you do that, if you install our ISO, you reboot, then you end up having a fully loaded Santoku Linux. You can do it bare metal. You can do it in a VM. What I'll show you today is running inside a VM. The only challenge that I'll mention when you do stuff inside a VM is that the virtual machine is going to sit between your device that you're investigating or you're analyzing and your host operating system, and they do something called USB arbitration. So they're passing that USB connections from your physical host through to the virtual machine. It works great on VMware Fusion if you're a Mac person. It works okay in other situations, but you sometimes have problems, especially with like iPhones running on Windows. So you run into some issues there. So if you have an old laptop lying around and you're tinkering around with this stuff and you can go bare metal, we've also dual booted this off of thumb drives, off of solid state drives, even off of a CD-ROM. So there's a number of different ways that you can do this. A VM is of course the easiest, but recognize that you may run into a few challenges if you've got some USB arbitration going on. So let me just take you through, and by the way, if you've got questions, please interrupt along the way. I'm happy to answer questions. No, apt-get would be assuming that you already have a Linux box that you're using and installed, and that's just going to put in all the different binaries that I'll end up using. Download the ISO, you don't have to worry about any of it, and it'll just boot up the way you see it. Yes? I have not tried doing it on Kali. They moved to .debs themselves, and it would probably work. We may conflict on a few tools. And at that point in time, there was still primary emphasis on pen testing and whatnot in the move to Kali, and they have some mobile tools in there. Our only focus is on mobile. And so we don't want to see 1,000 distros out there, but we really said, look, there needs to be one that's specifically focused only on mobile. So it'd probably work, but there may be some tools that conflict. I'm not sure. So when you say, what do you mean by that? Oh, you mean running like Android emulator, AVD? Yeah, you can do that. Yep, because we bundle the full Android SDK in there for you, so you can run AVDs as much as you want. Just make sure you give it enough RAM. Yes. That's a great question, and since I'm at OWASP, I should have a pretty good answer for that. I probably don't have the best answer for it. MobiSec, I believe, and correct me if I'm wrong if anybody knows, actually originally started as part of a DARPA or DHS Fast Track, if I'm not. And we took a look at that distro, but I think we found challenges around some of the tools and how it was maintained. So probably these are trying to do the same thing, but they're two separate distros. I haven't looked at their distro in a while, but we use ours. You'll find out that all of our products are built on top of Santoku, and every VM that I run, I just download Santoku instead of a normal Ubuntu ISO, because it already has ADB and the iPhone backup tools and everything pre-installed. So, but they're probably both trying to do the same thing. Great questions, by the way. I always ask people to ask, and then there's never any questions, so I love it. Via Forensics, we started out as a forensics company. It's still a big core part of what we do, obviously based on the name. And so I want to run you through just a little bit of background on forensics for those of you that may not be all that familiar with it. Forensic folks look at 3 different ways that we pull data off of devices. And back in the day when all we had to worry about were computers, it was pretty straightforward. Pull out the drive, attach a write blocker, dump all the data, and then go analyze it with some tool. And of course the challenge is in mobile phones, I can pull the drive out, but it's a lot harder. I got to do chip off, and I've got to reball it, and I've got to connect it up, maybe do some JTAG work. So it's really complicated, and obviously I remember early on going to conferences where kind of traditional forensics people would get into big arguments with mobile forensics guys and saying, well, you're changing the device and you're modifying it and you're installing an agent and you can't do this. And we had these kind of religious debates 4 or 5 years ago about mobile forensics. The industry's really come around and recognized that there are ways that we can have a very light footprint and that we can really detail what we do on the device. But unless you want to take every single case and go to JTAG or chip off, you're going to be making some sort of modifications. If we can do it in RAM only or from a bootloader where we never touch the core OS, great. If we can't do it, a lot of times in forensics cases, time is of the essence, and you need to get your hands on this data to try to figure out whatever the case is driving you towards. And so for that reason, mobile forensics is different than computer forensics, but conceptually there's a lot of similarities. So there's 3 types of acquisitions that we do. There's a logical, there's a file system, and there's a physical. And a logical file system is essentially the equivalent of like a backup. You ask the operating system to give you the files that it's willing to share, and it's going to hand you back some data. And that differs between iOS and Android and Windows Phone in how you do it and what you get. It's not going to give you deleted data. It's fast. The data is usually pretty well structured, so we know exactly what's coming back, and we can put them into the right rows and columns. It often limits how much data we can get, and you have to get around the passcode. Unless somebody left ADB debugging on, you've got to be able to get into the device. So that's one challenge you face on logical. File system is a step further into this, and basically saying, look, can I come back and instead of asking the operating system for a backup mechanism, if you will, let me ask the operating system to to share all the files that on the complete file system. And so typically you need privileges to do this. The advantage of doing a file system backup is that you get, again, well-structured data, and you'll see this in a minute. You know, files, database types, things of that sort. You can pull them all down, do your analysis. You get quite a bit more data, but typically it does require privilege on the device. The last thing, and it's kind of typically the goal of a forensic investigation, is let me do a physical image. And that, again, back in the hard drive days, was remove it, put on a write blocker, and have a ones and zeros copy of the original disk. And in mobile phones, you could do chip off or JTAG, or you could get privileges on the device and literally do like a DD, a bit-for-bit copy of the NAND flash drive, copy it off. The great thing about that is that we recover deleted data. And, you know, I testified 2 weeks ago in Dallas on a homicide case where the case essentially made a complete turn based on that deleted data and reconstructing what had happened. The challenge is that you're looking at a gigabyte or 16 gigs of raw data now, and you have to reassemble the pieces together by hand. Sometimes you can mount them as valid file systems, sometimes you can't. So it can be much more tedious. So those are just the three types of forensic acquisitions. I've been traveling a lot, and I'm supposed to have an iPhone in my bag, and the iPhone's sitting in Chicago. So I'm going to take you through the iPhone part of it with slides, and then I'll do live demos on the Android stuff. So iOS is one of the main platforms that we support. This is via logical acquisition. It requires that you put the PIN in. There's no way around that. But if you're sitting at home or at work and you're tinkering and saying, hey, is there sensitive data on this device that may put me or may put my company at risk? Here's a pretty simple way to do a test. You would put your PIN in after you've used your apps and synced up your data, plug it into Santoku Linux, and then you run this command, iDevice backup to. You give it the verb or the action to go back up, and then you provide it a backup directory. And what it's essentially doing is mimicking an iTunes backup. And it will pull down all of the files, and then the iTunes backup actually base64 encodes the data. And so you can run a second command that says unbackup this directory, so you turn it into real images and real SQLite files and things of that sort. And then you can simply go in there and view the data by hand and start examining the data. This is what the command looks like when you run it. It just basically connects. One of the things it does is it exchanges certificates. So you are modifying the device, and you have to recognize that, especially if you have to testify in court and things of that sort. But that's the way iTunes work. iTunes and iPhone work is that they exchange certificates, they establish a connection, and then they download the information. And so it just goes through, does a backup, pulls down all the files. Now, if you look at those files, they're all SHA-1s of the file name. So you take the sms.db, they SHA-1 and rename it to the long, SHA-1 signature. And it becomes very, very tedious to look at these things by hand. And so we bundled an open source software out there called iPhone Backup Analyzer. This guy, I think he's based out of Italy. He's doing his PhD, and this has become his PhD thesis. He's actually updated the tool since the version that we bundled in Santoku 04. So when we update to the next version of Santoku, you could just do an apt-get update and pull down the deb file. But we'll upgrade to his latest version, which he switched from TCL, from Tickle, to Qt4, and he wrote it in Python. So there's a lot of ability to just add a new parser in there, plug it in, and you're off to the races. But he'll take care of decoding the SHA-1s, having viewers for your image files, your SQLite databases, and you basically have a nicer way to rip through this stuff and look at text messages and images and things of that sort. But again, in the interest of time, I'm just going to skip through to the iOS. I'm more of an Android snob anyway, so and get to the Android stuff. So Android, we built a tool years ago called AF Logical, And we actually gave it away free to law enforcement. It downloads about 50 or 60 different types of information off of an Android device. But a year or two ago, we basically decided to open source that package. And so you can go out to GitHub right now, download the code, grab the APK, run it yourself. The open source version took 4 of the data types, call logs, SMS, a few things like that, and implemented those. But we didn't put all 65 of them in there. Anybody can go in and begin to expand it and add to it if they want, because it's just sitting out there. In Android, there's a logical mechanism called content providers. So it reads the content provider. So this is the way apps can share data, downloads it, and puts it into a CSV file. And we originally, to keep this simple, we just store it on the SD card. If you're doing a real forensic investigation, I don't recommend that. What you really want to do is what we've implemented in our commercial product is we added code in there to turn that into a server, essentially like a Netcat server. And so you read the content providers, we connect in over port 8001 or whatever, and we just talk to the agent and say, send me the SMS data, and it streams it out over Netcat over port 8000 using ADB port forwarding. So that's how you'd want to do it in a forensics instance, but this is more of a kind of open source free, mess around with it on your own device. And I'll go ahead and show you how that works. This is what the GUI looks like, because you're not going to be able to see it from here. But you push the app, you select, you have to make sure that USB debugging is on. You install the app, you run it, you select the type of data that you want to download, you click the button, it downloads it, and it saves it to the SD card, and then you can pull that data off. So these are the commands. They're a little bit hard to see, and I'm going to go ahead and switch now to my virtual machine. And I will hopefully make this so you guys can see it. Okay, first of all, is that legible at all, or can you guys not really see it? Yes? No, this does not require you to root the device. This is a logical acquisition only. Let me see if I can zoom in at all. Nope. All right. Is this big enough, or do I need to zoom in more for you guys? You guys can see it? Okay, awesome. All right, so I just want to so right now I have a Samsung device connected over ADB. He already has ADB debugging on, which means that I don't actually even have to have the passcode. I can just get into the device and pull the data off right now. ADB is called the Android debug bridge. It allows you to communicate with the device. I ran some of the commands earlier today to make sure that they're going to work, so I'm just going to cheat here and use my history. So the first thing that we're going to do is we're going to do ADB install, and we're going to install the open source APK. You can download that off of GitHub, you can modify it, you can have it do new things, whatever. So this is simply going to do an install so that you don't have to go to the Play Store or something along those lines and install it manually. So this is basically sideloading an app over ADB. And you can see that it downloads it, it pushes it to the device. It actually writes it out to data local temp, and then it does the install. Now from there, the app is actually sitting on the device. You could go in there, you could navigate, you could run it. But let's say that the device was locked and ADB was turned on, and you simply wanted to go in there and automatically run it. You can then simply come in here and just do a shell command to run it. And for those of you sitting up kind of close to the front, you'll see that on the Note 2 here, it's running, I missed an S. All of a sudden the screen changes and the GUI pops up. Now we made it where you actually have to hit the button for capture, which I'm going to do here. Capture, it took 2 seconds because I don't have a lot of data on here. It put the data out onto the SD card. And then you basically can come in here, and there's a command in ADB called ADB pull. And I'm just going to create a directory here called AF logical data, and I'm going to pull the data down off of the SD card. So what it's doing right now is it's doing a recursive pull, grabs that directory, brings everything down to the local file system, and then we can come over here, view the local file system, and you'll see that we only brought in a few pieces of information I can tell you there's 60, 70, 80 things like this you can pull down if you just add the content providers. We didn't put that into the open source one, but anybody can make those modifications. So we pull in call logs, contacts, MMS, and SMS. And one of my MMS pictures happened to be, we're working on a project where we're breaking into locked burner phones, something that DHS sponsored. So looking at the bootloaders, finding vulnerabilities, it's amazing how many of these things we can get into. So if you're a drug dealer and you're doing burner phones, be careful. I don't know if any of you guys are. But so this is just a picture of all the phones that we were working on as they came in and got shipped in. But it's pretty interesting. You can pull this data off. You can look at, we bundle something, all of the data about the device in an XML document. So you can pull down and see here, see if I can zoom in, things like, what was the date time, what was the IMEI, IMSI, phone numbers, what are the hardware versions that you're running. And then we actually pull down every single application so that you've got data. And for this case that I did a couple weeks ago in Texas, it was a bad case. And if you're from Texas, you probably know about it. But this guy ended up installing an app called Fake SMS and Call Logger. And he faked text messages and phone calls from his victim, trying to prove that she was lying and things of that sort. But he had uninstalled the app. And so the Secret Service had done their investigation using Celebrite, and they saw from a list like this that the app had been installed but was no longer installed. So it wasn't on the device anymore. So you can use information like this to see what was there, see if it's still there, and then what we ended up doing is that we knew it had been deleted, so we went in and did a physical image on that device, and when we ran our recovery against that physical image, we found the data about the application, we found all the text messages and call logs that he had faked, and we were able to piece back together the entire timeline of what had happened. So we provide you that information here, at least about the apps and the phone and whatnot, is in an XML document that you can view and you can parse. And then, for instance, this is my demo phone, so I use it as I'm going around at different conferences. I was in California a couple weeks ago doing a demo, and one of the guys that worked for me left his G-Nex on the table. Anytime I see a phone on the table, I assume it's mine, so I grabbed all the phones and shoved them in my backpack and went back to my room, and then 10 minutes later, I got the frantic call from him saying, I can't find my phone anywhere, do you have a G-Nex sitting in there? And of course, that's kind of the history that you're seeing here. This is Ryan asking me about if he left it, and then I said, yeah, I found it, hey, I'm on my way to the lobby. So you'll be able to pull in hundreds, thousands, tens of thousands. It's amazing how much people text message. We had to rewrite our app because we were helping an agency with a child exploitation case, and this guy was talking to all these kids, and he sent over 50,000 text messages a month. And our application initially was written to read the entire SMS, write it to a file, and then send it out. And we had to start chunking them in 2,000 chunks at a time because there was so much SMS messages going on. This was back, I think, on an Android 1.5 or 1.6 device when they only had a half a gig of RAM or 256 megs. But in any event, this is out there. It's freely downloadable. Anybody can use it. And I'll just show you one other thing. So we actually have a free tool out there where you can download vExtract in a demo version. And it'll take those 65 content providers that I talked about, and it'll give you data from all of them. It'll just give you the first 10 records only. And this is a beta version of our latest. So what we do as a company is we take these command line tools, which is what we use, we build them, we open source some of them, and then for our commercial products, we wrap a GUI around it. And I'm not going to take you through the whole acquisition process, but I did one this morning real quick on this same device, and uses AF Logical behind the scenes. And I'll just give you a sense for, instead of just pulling down a few things, what you can really end up seeing in these, browser history, browser searches, which always scares me. Luckily, there's nothing embarrassing there. The bookmarks, and I actually ended up stopping it at one point because there were too many videos that were getting pulled down. This is actually me talking at ThoughtCon earlier this year, and one of our guys had grabbed this phone and we're taking pictures of it. So on this phone alone, there's probably 20,000 pieces of data you can pull off of it using a more comprehensive logical analysis. And so just kind of giving you a sense for, what does it look like if you can actually end up generating a report that will pull down all of the data, put it in a nice little format for you and let you know, what was all pulled down, have you little pictures and thumbnails of the websites that you visited. And this was really, really important. That's not my Facebook page, by the way. This was really important in the latest case that we did, because we were able to go back and recreate the actual web pages that he visited. He was logging into Facebook as 3 separate users and was basically trying to set up a relationship with this girl using fake Facebook pages as well. So this is the kind of data that you can pull off simply from a logical analysis. Okay, I need to speed things up a little bit. Mobile security. Just give you a quick background for those of you that came from a security standpoint. Mobile, there's a lot of overlap between traditional security, web app security, and mobile, but mobile combines quite a few other things together. And so we often say mobile has a large attack surface, bigger than a web app, because the web app, you're typically going to pen test the web server, SQL injection. With a mobile app, you have to worry about the device, the app, encryption. You have to worry about networks like man-in-the-middle and DNS spoofing. You have to worry about also things like SQL injection. That's a big mistake that we see mobile app developers make. They think because the data is coming in from an app that they control, they don't have to worry about sanitizing it. And we'll simply go through and look at the URLs that they connect to, skip right around the mobile app, hit their website with their permission. We'll fuzz those services. We'll do SQL injection attacks, input validation errors. And it works. It works beautifully. So if you're in an InfoSec team at a large company, really start to encourage the devs to think about, and in fact in your own analysis, it's not just about doing some static analysis on the app or on the code. It's really a much, much bigger attack surface in the mobile world. And so just to kind of illustrate this for you, we have a mobile security product that does security testing on iOS and Android. And we regularly run apps through that off of the App Store just to test our application, make sure that it's operating properly. So recently, we looked at about 80 apps, finance, lifestyle. They're basically the most popular apps that you can find on the App Store for both iOS and Android. And here were the findings that we had. 15% of iOS, 20% of Android apps fail man-in-the-middle. Now, that is completely solvable and, frankly, completely inexcusable. One of the things that dawned on me recently is more and more websites, consumer websites, are asking for good passwords. And as a typical end user, you can't type in pass123 or 12345 anymore. So what do? You go back to a complex password that you remember. Well, what's the complex password that you remember? It's the one that work forced you to do when you log into the domain. So, back in the day, I'd say, well, somebody got your Facebook password. So what? I work at a company with a domain and a complex password. Well, my contention is, and maybe it's not supported by the password dumps that we get right now, but as more and more websites force better passwords, the end users are simply going to say, I'm going to use that one password that's already in my brain that work made me do. And so, that's why man-in-the-middle matters. If I know your first name and your last name, if I know a bunch of data that 10 to 15% of your apps are sending across the network about you, and I know the password or passwords that you use, is that enough information for me to get inside your corporate persona? Maybe. It certainly gives me a huge kind of leap start on this, head start on it. So completely solvable, completely inexcusable, and it's still happening at a very alarming rate if you ask me. The second one I'll point out to you is that storing passwords in plain text. You should never store a password. And if you store it and you hash it, okay, fine, but you're probably going to assault, a brute force or rainbow tree attack, or rainbow table attacks. But these are apps that are storing it in plain text. So 25% of iOS apps that we tested store your password in plain text on the device. So the forensic techniques that we're talking about today will recover that password immediately. And then, in memory, I think that's less of an issue, but just kind of look at that last category. When we look across our mobile security testing, 75% of iOS, 60% of Android apps fail at least one high-risk category for us. And that's, yes? I think that's a great point. There certainly is bias here because we're choosing the most popular apps for iOS and Android. And even though banking apps are popular, they're not as popular as Facebook. They're not as popular as other apps along those lines. But what I will say is that this is skewed much more towards companies that make money on mobile. If you're going to be in the top 50 apps, you either have a business model that you're having more touch points, or you have a direct, purchase business model where they're spending money on your mobile app. So this doesn't represent the guy or gal hacking out code in their apartment, and I can tell you that code's a lot worse. So there's definitely bias here. It's a very small sample. There's a million apps out there. You can't take 81 and say that's a representative sample of the entire app store. But my contention will be we'll probably see worse statistics as we expand into the less, because the bigger companies do have QA, they do have security folks, they do have people go to training, and the other folks don't, they just don't do that. These should be, in theory, because they're on 100 million phones. Real quick too, why is mobile security difficult? Well, there's a lot of people in this dance, all right? There's the OS developers, that's Apple and Google. Of course, it's Microsoft and Samsung with ties in, and a bunch of other folks. But let's say it's Apple and Google today. You've got the device manufacturers, the Samsungs, the Toshibas, and then you've got the wireless carriers. All three of these guys write code with system or root privileges and deploy apps to your phone, apps that you typically can't remove. And the latest phone to own in Japan, Samsung S4 fell. The reason it fell was a bundled Samsung app. So these guys are pushing apps to your platform that you may be using for corporate or your customers may be using, and there's a lot of vulnerabilities in them. The app developers themselves, we've already kind of touched on that. They're either professional app developers or they're coding at night. Either way, we're finding that the app developers don't have the training that they need. And in fact, not only do we have our best practices document, it's about 40 pages long, that says how do you not make these mistakes. We partnered about a year ago with CompTIA. And a couple weeks ago, CompTIA released their Mobile App Security Plus certification. It's like $250. It's certified from them. It's not just a small company saying, oh, come to us and get a cert. So it's a real company that does certification, and they do it for iOS and Android. So if you're looking at something that you could run your devs through to kind of up their game, there's a certification out there that came out a few weeks ago that we think is going to start gaining some traction in the industry. Companies, of course, are trying to protect their mobile devices. And last but not least, you can't take the end user out of this because maybe your kid wanted the latest version of Angry Birds but didn't have the credit card number, so they sideloaded it from a website somewhere, and it happens to be Trojan. So these are all the actors that are involved in that mobile security dance. So I'm going to pick on a very public app here. Any.do has 5 million users. They're one of the worst mobile apps we've ever looked at. They exemplify, they take our commercial via lab product and they demonstrate every capability to its fullest extent because they fail every security test pretty much. And we've done full disclosure to them. We've reached out to their CEO. We've called their offices. We've contacted them on Twitter. We have absolutely no response from them. So 6 months ago, we did a full disclosure on our website. Some security geeks noticed, and then everybody else forgot about it. And on marches any.do, putting pretty much any of their users at complete full risk. And so we have a write-up online about it. You can go check it out. What would you do then to take a look at any.do using Santoku Linux? And so I'm actually going to run you through it from a slide standpoint here, and then I'm going to demonstrate it live with malware because there's a very similar process that you run through. There's some precautions you take when you're looking at malware. But one of the things that we're really big on is forensic analysis. So run the app, use it, and then ADB pull the data down just the way we did from the SD card, but now do it from the application directory, and go look at those files and try to understand what data gets persisted out there. How is it stored? And then second of all, get into some basic dynamic analysis, which you can do with Santoku Linux as well very easily. So what we end up doing is we have a little Wi-Fi dongle that we attach to the computers, the laptops. You could use built-in Wi-Fi if you want. But we take Santoku Linux, attach your Wi-Fi to it, and turn it into an access point. And then you take your mobile phone, and you say, instead of getting out to the internet over cell or some other thing, have it go out the internet through Santoku Linux. Now you've basically become the man in the middle, and you can do any sort of security testing that you want. It's very, very simple, and I'll show you the commands here how to do it. So then it allows you to basically run the app, capture the traffic, and begin to do analysis on what's sent in plain text. Could we man in the middle then? Can we do SSL strip? You can even push your own certificate to the device, certificate authority, mark it as valid, and do full SSL interception and basically look at the proxying and understand what's going on. So when you take a look, and this is a screenshot from iOS, when you take a look at the data files that any.do leaves lying around, you'll end up finding right here, and it's maybe a bit hard to see, sitting right inside the preferences file, they have password, and here's your password, username, all that information stored in plain text inside the plist files, as well as inside the database files on Android. So by just running the app and then pulling it down, the data, you can do a simple grep command and see the information. And let me switch back real quick to this and show you how you might do this from a command line. So one of the things about Android is, oh, let me reconnect my device here. One of the things about Android is that you can basically, okay, we're back online. You can go through, and again, this is a rooted device, so bear in mind that when you do security analysis and you want to get to the data directories and intercept PCAP and all that, you've got to have privileges on the device. So have a special device that you use for security testing. But here, I'm just doing a quick listing of every app that's sitting in the data directory. And you can, if you're a command line person, you can easily run that through grep and look for any.do or any other app that you want. So, here is the, any.do. So you could simply come here and say adb poll /data / what is this one? com.anydo. It's going to build the file list, and he's going to pull down all the files. And then we could come in here. And I should have put it in its own separate directory. But here you've got, for instance, the databases directory. And here's all the different databases that any.do creates. And you can literally open those things up. You can grep. You can grep for different patterns and look through the data. So pulling down the forensics, looking at the information. And I'm actually going to switch VMs here first. So you have to bear with me for just a second. Because I want to bring you guys into a secondary VM that I have where we typically do our via lab and we do our security analysis. So give me just a second to switch over here. Okay. So I'm going to show you what this looks like more from a, if you wrap a GUI around it, if you get tired of doing the analysis by hand. Let me attach my code meter. And while I do that, let me flip back to my slides real quick while that brings up and running. So basically what I'll show you here is that you can do these things by hand by doing ADB poll, by doing man in the middle and routing your network traffic, and I'll show you that in just a minute on the malware side. What we've done is again, we've taken those things and we've wrapped them in a PyGTK interface and make it really easy to just pull down the artifacts, examine them, look at the information, and it's really the fastest way for me to show you the data. And then we spit out a report, and we basically say, hey, what information did you find? Where is it located? And put all of those artifacts and all of that data kind of at your fingertips. And let me just bring it up real quick because I already did it. So the nice thing I like about this is that I'm sitting at conferences and I'll literally just pull up an app, and in 10 minutes you can rip through a security audit. And it makes it really easy to come through. So for these guys, we found username, password, and the keywords. And if you're doing the greps by hand, you can come down here and basically see where each of the files are located. So we found the username via forensics test in the databases data directory. The password was there as well, as were the different keywords. And then we actually found the keywords in the plain PCAP as well. So if you're capturing PCAP on the network here, and we bring things up in hex because we're forensics people, you can do strings, but you can easily come in here just to like Wireshark, launch that out, And because we found it in HTTP, you can go through the HTTP traffic really quick, and then start looking at, what information are they sending back and forth in plain text. And you end up finding that pretty much all of the data that they're passing around is interceptable. And so by looking at the forensics data, by looking at the, the application data, you can see how the app is behaving. You can do both static and dynamic analysis. Here in the forensics view, you can see they have a database called data, and they have a journal file as well. So journal files are where SQLite caches the data, and I'm going to do a quick strings on it. When you look at the journal file, you end up finding that SQLite does both write-ahead logs and journal files. They temporarily write data to the disk so they don't lose it in case you lose your power, and then they convert it and eventually write it back to the SQLite database. So in here, you'll end up finding that the journal files are tracking all of the information. And so if you're looking at your own app for your own company, take a look, because you may say, hey, we're always writing this data, but they delete it and it's never stored on the device. Well, that's not going to be the case. Typically, we'll recover this data through journal files or through other techniques. And so they were storing all of the information in the actual data directory, in the database called data, under a preferences flag. And if you look here, you go into preferences. You flip through here, at the bottom you'll end up seeing, here's your username, here's your password, here's a bunch of base64 encoded data, some cookies, some strings, and things of that sort. So by pulling down the PCAPs, by pulling down the forensic data, you can do some simple forensic and dynamic analysis on any app. And you'd be doing it from command line. And I just realized I have 5 minutes. I thought I had till 9:15. So let me switch back to malware analysis. I want to point out an interesting app to you guys called NQ Mobile. It's a publicly traded company. It's an antivirus. It's based out of China. We did some analysis on it because Bloomberg asked us to. And it's supposed to be an antivirus, but it ends up reading your contacts, your SMS. It reads your IMEI, IMSI, your installed apps, the websites that you visited, and they send them to 3 different servers. Send them to 2 servers in China and 1 server in San Jose on the Amazon cloud. The San Jose server, they actually send everything port 80 plain text. In one of the Chinese servers, they send it AES encrypted, but they bundle the key with it. And in the other one, they do an XOR with 0x6, basically, encryption. And the other thing that this app does, and it's really surprising, is they actually try to run SU on your device. And if they can run SU, they try to mount your system partition read-write. And then they have kind of a BS a business model where they set them 2 fake virus alerts every time you run it after about 10 minutes. So we ran it in an emulator with no other apps installed, and lo and behold, they found 2 viruses on the emulator. Why do I show you that? That's not malware, right? Because none of the malware vendors tracked it, and it's a legitimate company, and maybe they're just really bad coders, and they over-permissioned, and they're sending your data to China, and they just forgot, and they shouldn't be doing it. But a lot of CISOs would look at that and say, I'm a little bit concerned with that. So my point is the next 2 examples, which unfortunately I'm not going to have much time to go through in a live demo, these are real pieces of malware. So these are ones that have been downloaded off the malware lists. This is a Russian malware targeting. They're going to download other apps. It's an advertising network. And we bundled tools called APK tool. It's going to allow you to reverse engineer the app with a simple command. So you basically just run the command right here, APK tool D, and then you give it the name of the APK and then the output directory. It's going to reverse engineer the app, pull out all the assets and artifacts, stick them in a directory, and allow you to just look at them, examine them. And one of the simple things you can do is you can grep and look through some things. So one of the things we always look at is are they requesting your device ID? Because that's a piece of information you can then use to try to impersonate the device, download apps. This one registers on boot complete, which means as soon as the phone finishes booting, they're going to register as a service and start doing things. And what do they end up doing? They end up registering and flashing up an ad network, and then basically make it so that when you run, they can send another APK to your SD card and have you install that APK basically from a website. So they're going to sideload other malicious apps onto your onto your device. And you can basically get to the bottom of this by looking at some of the code. And if you don't want to do a command line, you can run something called dex to jar. And let me see if I can, probably in my other VM. And I know I'm going to run out of time here, so there's a command called dex to jar. So you basically take any APK file, you run dex to jar, and it's going to create a jar file, and then you can open it up with a tool called JDGUI. Those are both sitting on Santoku Linux and ready for you, and it reverse engineers it and allows you to examine the code in a very readable way. And this is where here you can see that there's an install method. They actually install the file from mount SD card download. And so what they do is they download it from the internet, they save it to your SD card, and then they sideload that APK file. More interestingly, we just looked at a Korean banking malware. We didn't know it was a Korean banking malware until we started looking at it. Android apps are zip files. And inside the zip file, you can do things to confuse the reverse engineering tool. So the first thing these guys did was started sending encryption flags in the zip file, saying, hey, this is an encrypted zip file. Android ignored that and still ran it as a valid APK. But all of the other tools that use zip to unzip it and then do their analysis got confused, thought it was encrypted, and then failed. So this was a way for them to try to make reverse engineering tools fail. So my guys ended up flipping those flags back. And what we ended up finding is that this targets these 4 banks, these 3 or 4 banks. It installs, it tries to get around reverse engineering through the encryption flags, and then it registers with high priority to intercept packages as they're installed and uninstalled. The reason is they want to uninstall the Korean banking app, and they want to reinstall a Trojan version. So you'll never notice the difference. So they look for those guys, they uninstall it, they reinstall it, and then once they've done that, they intercept your SMS. They ended up running off a LAMP server that had a lot of vulnerabilities. So some guys went out there and popped to their server, got shell on it, dumped all their data, et cetera, et cetera. But they ended up registering content providers and SMS receivers, and that was their command and control. So last parting thought here, I'm going to send this out on our website. Here's the commands you would use to reverse engineer to do the dynamic analysis, some of the man-in-the-middle traffic. We're beta on a product that's free. You install it on your Android phone, and it begins to profile the apps and what IPs and ports they're talking to and things of that sort. As you think about looking at your organization and saying, hey, what apps should I even be looking at, you might want to take a look at a technique like this, because you can be profiling your devices in real time and basically saying, hey, what apps, what ports, what servers, where are they located, who's sending data to them? And then you can begin to say, what are the apps that I want to start looking at? So I know I'm out of time here, and I'm really sorry that I ran late and did to get to some of the interesting stuff. Santoku Linux is an open source. The tools are all bundled. We don't get a lot of help from the industry. That's fine. We use a lot of open source tools. We don't help them out very much too. But if you are interested, we're always looking for how-tos. We're looking for people to contribute to tools and development, give us some advice and some feedback. So contact us online, give us a shout out on Twitter, whatever, and we'd love to hear from you guys. So thanks for your time today.